Good day everyone, welcome to the Certified Math Majors channel. In this video, we will be learning how to do a shortcut process of integrating by parts. But before anything else, I'd like to remind everyone that this shortcut procedure that we will be doing here is only applicable for functions that is a product of an algebraic function and either a natural exponential function or a trigonometric function. Just like in this example here, you have x squared e to the x dx. Now notice the function is a product of x squared, which is an algebraic function, and e to the x, which is a natural exponential function. So this shortcut method is applicable only to these types of functions that are being integrated. Now, I intended to show the solution here so that you will be able to appreciate the beauty and the convenience of the shortcut method that I will be teaching you here. Because as you notice, if you're going to follow the solution for this problem here, which is the integral of x squared e to the x dx, notice that it involves two integration by parts. The first integration by part happened here in this part. Now, this first integration by parts resulted into this expression. And this integral here needs to be removed. And to remove this integral, we need to have another integration by parts, which is this part here. It ended up with x e to the x minus e to the x. And then we simplify. This one here is this one. And then 2, this integral here now becomes this one. So we simply substituted. So this is now your final answer. You have x squared e to the x minus 2x e to the x plus 2 e to the x plus c. Now, if we're going to do this integration by parts by ourselves, obviously that's quite long. So there's so much time that you need to spend in order to integrate this one. Not to mention the confusions of the signs that you might encounter along the way. So in order to avoid or at least lessen these mistakes and to, of course, shorten the time in solving this type of uh, problem, we need to do the shortcut method. Now, I call this shortcut method the DI method. You have D and I. Now, the D stands for differentiate. I stands for integrate. Now, these two methods or these two acronyms, the D and the I, is applicable to each of the functions that are given. Now, the D, we're going to apply it to the algebraic function. That means we are going to differentiate the algebraic function. So, we differentiate the algebraic function until it becomes 0. So, you have first x squared. Derivative of x squared, you have 2x. Next, differentiate again, that's 2. Now, derivative of 2 is 0, so you stop there. So, this is now the derivatives, all the derivatives of the algebraic function. Next, for the I, that's integrate, we are going to integrate the transcendental function, which is the natural exponential function. So we integrate immediately, unlike in the differentiation wherein you have to copy first the function. When you do the integration, integrate it immediately. So in the first part, you now have the integral of e to the x, which is still e to the x. Now, since you had 3 differentiations, you will also have 3 integrations. So, integrate e to the x again, you will still come up with e to the x, and then integrate e to the x once more, you will come up with e to the x, because the integral of e to the x actually does not change. So after doing the D and the I, we need to assign a scheme of signs for the products of these two. So the signs of the product here in the first column is positive, next column is negative, next column is positive. So it just alternates, starting with a plus sign and then alternate negative, then positive, and then so on and so forth. Now after this one, we simply have to multiply the expressions that we have in each column. So you have x squared times e to the x, that gives you x squared e to the x. And then 2x times e to the x is 2x e to the x. Since the sign is negative, multiply it by negative, you now have negative 2x e to the x. And then lastly, 2 times e to the x is 2e to the x. Sign is positive, so you have positive 2e to the x plus c. Now, this gives you the same answer here as we integrate by parts. So, you can see that the shorter method gives us the same answer. Not only that, it gives us much more convenience because of the fact that we were able to get the correct answer in a much lesser time than the usual long method of integration by parts. So next example, we have this one. So this is kind of long, so let's try to zoom in here. So this is the example. You're going to integrate x cubed sine x dx. So algebraic function and then a trigonometric function. So the shortcut method that we are employing here actually applies. So to solve this one, we're going to have this one here. So this is the long method. So the long method, this is the first integration by part here. This leads you to this expression. This expression, you need to do another integration by parts, which leads to this expression. For this expression, you need another integration by parts for this one until you come up with the final answer below. So this one here, that's your final answer, the one inside the rectangle. So notice that there are 3 integration by parts that is involved here. So you just imagine the time that you have to allocate just to complete all these 3 integration by parts just to solve this very simple problem here. So we're going to use the DI method again. You have the D and then the I. So the D, we're going to differentiate the algebraic function. Our algebraic function is actually x cubed. So you have x cubed. Differentiate it until 0. So you have 3x squared. Then you have, differentiate this again, you have 6x. And then differentiate this again, that gives you 6. Now, derivative of 6 is 0, so you only have to stop until 6. Next, you integrate the trigonometric function. So, trigonometric function is sine. So, integral of sine, so you integrate now. Integral of sine is negative cosine x. Next, you integrate now. Integral of negative cosine is negative sine x. Integral of sine x is negative cosine x, but since that's negative, that's positive cosine x here. And then integral of cosine is you have negative sine x. So assign a series of signs for each column. You have positive, negative, positive, negative. After that, multiply everything. You have x cubed times negative cosine x. That gives you negative x cubed cosine x. Then, this one here, 3x squared times negative sine x is actually negative 3x squared sine x times negative, so that gives you positive 3x squared sine x. And then this one here, 6x times cosine x, that gives you positive 6x cosine x. And then lastly, you have 6 times negative sine x is negative 6 sine x times negative, that gives you positive 6 sine x plus c. This one here is just the same answer as this one. So you see how much shorter the technique that we have applied as compared to the usual integration by parts. So that's all for this video. Please don't forget to like and subscribe to our channel for you to be updated on our next videos. So that's all for now. Thank you so much and enjoy learning.